In this problem, we are told to use the formal definition of limit, which is the epsilon-delta definition, to prove the following limit. So I'm going to begin with the first one. We have to prove that the limit as x approaches 3 of x squared minus 9 over x minus 3 is equal to 6. Of course, what does the formal definition say? The formal definition says that for every epsilon greater than 0, there exists some delta greater than 0, such that if the distance between the x and then the point 2 being less than delta, then we have that the distance between the function and then the limit is less than epsilon. So this is the formal definition of limit, and this is what we are going to use to prove this question right here. All right, so let's begin. Now, I'm going to do what I call exploration to choose. In other words, I need to choose some delta in terms of epsilon so that I can use that to prove that indeed the distance between the function and then its limit is actually less than epsilon. Right. Oh, sorry, this is supposed to be 3. Yes, it is x approaching 3, so it is x minus 3. Sorry. All right, so let me do what I call exploration to choose my delta. And I'm going to start with f of x minus L. Of course, f of x is x squared minus 9 over x minus 3 minus the limit L, which is what, 6. Right. And this should be less than epsilon. Now you agree with me that this numerator, we can use difference of 2 squares, right? That would be x squared minus 3 squared. And in using difference of 2 squared, we have x minus 3, and then we have x plus 3, all on x minus 3, minus 6, and this should be less than epsilon. Clearly you can see that this cancels this. And then finally we are left with x plus 3 minus 6, which is less than epsilon. And this is also equal to x. Of course, 3 minus 6 will be negative 3, so x minus 3 being less than what? Epsilon. But we know that x minus 3 is actually less than delta. So comparing this with this, I can choose my delta to be equal to epsilon. So now that I have chosen my delta to be equal to epsilon, I'm going to use this to prove that indeed the distance between the function f of x and its limit is less than epsilon. Alright, so let's now begin the proof. So now I choose my delta to be epsilon, and then I use that to prove. So choose delta to be equal to epsilon. Then now I start the proof. So f of x minus L is actually equal to x squared minus 9, all on x minus 3, minus the limit 6. And this is equal to, the top is difference of 2 squared, x squared minus 3 squared, all over x minus 3 minus 6. And of course, using difference of 2 squared, the numerator will be x minus 3, then x plus 3, all over x minus 3, then minus the limit 6. And clearly you can see that this cancels this, and we are left with x plus 3 minus 6. And this is equal to x. 3 minus 6 is just negative 3. So we have x minus 3. Of course, we know that this expression here, the x minus 3, we know that it is less than what? Delta. It is bounded below by what? Delta. So in place of this, I can say that this is less than what? Delta. And of course, we know that I chose my delta to be equal to epsilon. So clearly, this is equal to epsilon. And I have been able to show or proved that indeed the distance between the function and its limit is actually less than what? Epsilon. So that is for the first one. In the second one, we are told to prove that the limit as x approaches 2 of x squared plus 2x is equal to 8. So we are going to do the same thing. Okay, let me clear this so that I will have enough space to do the second one. So a minute to clear this. All right. Of course, we are going to use the same definition for every epsilon greater than 0. There exists some delta greater than 0 such that the distance between x and then this point, this where x is approaching, that is 2, such that if this thing is less than delta, right, if this is less than delta, then the distance between the function and its limit is less than epsilon. So with these two, I'm going to do an exploration to choose some delta, which will help me to prove that the distance between the function f of x and its limit is less than epsilon. So let me do my exploration. I'm going to use this to do the exploration. So I know that f of x minus L is equal to, now f of x is x squared plus 2x minus the limit, which is 8, and this thing should be less than what? Epsilon. Of course, what we have here is a quadratic equation. So if you do factorization, the factors are going to be x minus 2 and then x plus 4 being less than epsilon. Right. Now, we know from this definition that we quoted that x minus 2 is less than delta. Right. But we need to bound x plus 4. Right. We need to bound x plus 4 so that we can easily choose our delta in terms of what? Epsilon. Now, in bounding x plus 4, I will restrict, what I'll do is I will restrict x minus 2 to be less than 1. This is because I want to keep x close enough to 2. That is why I'm restricting this to be less than 1. Now, if this is the case, then what it means is that x minus 2 lies between -1 and then 1. And of course, if I add 2 to both sides, in fact to all sides, I will have 1 here because 2 minus 1 will be 1. If I add 2 here, I'll just have x because minus 2 plus 2 will just be 0. Less than if I add 2 here, I'll have 3. So this implies that x belongs to the open interval 1, 3. If that is the case, then I want to bound x plus 4. So I will add 4 to each side. That will be 4 plus 1 less than x plus 4 less than 3 plus 4. And that will be, sorry, this is 4. And this will be 5 less than x plus 4 less than what? 7. Which tells me that x plus 4 belongs to the open interval 5, 7. In other words, x plus 4 is bounded by 7, so it is less than 7. So now that I have been able to bound x plus 4, I can continue with my exploration. Okay, so let me continue from here. So from here, I'm continuing. I have x minus 2, then x plus 4 to be less than epsilon, right? Of course, so we know that I restricted x minus 2 to be less than 1, right? And then x plus 4, I've also bounded it to be less than what? 7. That means that my x minus 2, the distance of x minus 2 will be less than epsilon over what? 7. Because I've bounded this. Oh, of course. Okay, let me make it very simple for you to get it. So this will be x minus 2 multiplying 7 less than epsilon, because I've bounded x plus 4 to be less than 7. And I'm going to have x minus 2 being less than epsilon on 7. So here, comparing this with this expression, I'm going to choose my delta to be equal to the minimum of 1 and then epsilon on 7. So I'm going to use this to prove that indeed the limit of this expression, x squared plus 2x as x approaches 2, is equal to 8. Alright, so let's now begin the proof. So mostly I do exploration just to choose my delta in terms of epsilon, so that I can easily prove that the distance between the function and its limit is less than what? Epsilon. So now I'll begin my proof, but I'll choose delta to be equal to what? The minimum of 1 and then epsilon on 7. So now let's begin the proof. Now f of x minus the limit L is equal to my f of x is x squared plus 2x minus the limit 8. And this is a quadratic equation. Of course, just like doing a reverse of the exploration. So we are going to have x minus 2 and then x plus 4. Right? And then of course here we bounded x plus 4 to be less than 7, if you remember. Right? That is what we actually did. So we are going to have x minus 2 because we bounded this, so this will be less than, because we have bounded this to be 7, so multiplying 7. But we know that this is also less than what? Delta, right? And we chose our delta to be the minimum of 1 and then epsilon 7, so I'm going to use epsilon over 7. And so this will be equal to, of course, delta multiplying 7, and then I know that, let me use less than or equal to. And this is equal to, my delta is what? Epsilon over 7 multiplying 7. And clearly you can see that this is equal to epsilon. So indeed, I've been able to show or prove that the limit as x approaches 2 of x squared plus 2x is equal to 8.